Hello. In this video, we're going to go through finding the median of a triangle. Now, really important is we need to know what a median is. So this is a definition you definitely want to add to your skill set. So let me draw a triangle here. Let's just make a general triangle. Okay. This is not any type of specific type of triangle. This idea applies to right triangles, isosceles triangles, equilateral triangles. Any type of triangle this property applies to. And if you don't know the different types of triangles, I do strongly recommend you go back and take a look at that. So a median, simply put, if we call this triangle ABC, the median of a triangle is the line that goes from a vertex to the opposite side's midpoint. So the midpoint, let's say if BC is here, the median through vertex A would be that line there, or line segment. Now there's lots of things we can do with this. We could calculate the slope of the median, we could calculate the equation of the median. But one thing to take note of and recognize right away is that all triangles have three medians. So now a question that often comes up is, what are medians useful for? There's all sorts of interesting geometrical properties that are useful in a wide variety of applications. One interesting thing is that let's draw all three medians on here. So and I'm approximating here, bear in mind, this isn't exact. So the midpoint of AB is there. So there are my three medians. And what you might notice is that I've actually gone and drawn them so that they all intersect at the same point. And that actually is by design. It turns out that all three medians will intersect. And that's always the case. And that point is actually what's called the intersection point. It's called a centroid. So a centroid is a point in a triangle where your three medians intersect, and it's actually a pretty cool thing in terms of some, for example, in engineering, because if we have a triangle, say, that's of uniform density, meaning it's made of the same material, the same thickness, that centroid is a point of balance. I can actually put my finger on that centroid or put a beam there, and that will balance perfectly. So it's an interesting point in the triangle from a building standpoint. Lots of interesting things about the centroid of a triangle. That could be a whole set of videos unto itself. But let's go down here. Let's actually do an example. Okay, so find the equation of the median that passes through A for the triangle with vertices. A is 1, 1, B is 5, 5, and C is 3, 7. So in this case, I've drawn a picture using GeoGebra and I've pasted it in here. But one of the things that I really want to stress is always draw a picture. Pictures are so important. And when I say picture, I mean a graph. They don't have to be perfectly to scale. They should be approximate in nature, because as you move forward, you don't typically find things from a graph. A graph or a picture is all about giving you clues as to what to do next. So when I get a problem I don't know how to do, I often draw a picture. And that kind of helps me figure out the next step, and I can often see different things by looking at that graph. Anyways, I'm rambling about that too much now. So let's get back to this problem. So if I want to find the median that goes through the vertice A, essentially what it is I need to find the midpoint of CB. And now this problem is really nice because we can just put it in there, and then I want to find the equation of the line that does this. Okay. So once I know what a median is, I see that this problem is simply find the equation of a line given 2 points. That's all this problem comes down to. So we're going to call this is called the midpoint of CB. So again, this diagram is the scale. It works nicely. Let's make sure we understand the algebra in case it wasn't a nice case. So algebraically, the first thing I'd have to do is calculate the midpoint. So the midpoint of the formula, and let's write this down, is x1 plus x2 over 2, y1 plus y2 over 2. So that's the midpoint formula. Again, a good passive memorization technique is just to write it out every time. And then the midpoint of CB, therefore, let's make that a little bit nicer, CB is equal to, so let's take the value of C, so that's 3 plus 5 over 2, and then 7 plus 5 over 2, which perfectly works out to 4, 6. Awesome. So now that I have that point, this problem becomes, let's call this line 1 on the diagram, so now I have something to help understand my solution. So line 1, and if we want the equation of a line, we're going to ask ourselves, what's the best form here to use? Now, typically, we use the form y equals mx plus b. But remember, you have all sorts of different forms at your fingertips. But this is the most standard form, and what I need for this is I need the slope. So I'm going to ask myself, what's the slope? And I need to find the y-intercept. So again, this is a pretty nice question insofar as I can read the slope right off the graph. So I'm going to figure out the rise over the run. So to go from A to MCB, I'm going to go up 1, 2, 3, 4, 5 units up. I'm going to go across 1, 2, 3. So that means the slope is 5 over 3. And of course, I look at the slope, and then I look at my picture, and I feel good about this because the slope is positive. One of the nervous tics we want to develop as mathematics students is you always want to be asking yourself, does that look right? Does that look right? Does that look right? If you constantly ask yourself this question, you're really going to catch those small mistakes. And speaking as someone that makes a lot of small mistakes, trust me when I say it's very useful to constantly ask yourself the question, does that make sense? So now let's find B. Now I could extend this graph here, but it actually, I've just moved the screen on us here. Let's put that back, there we go. You can actually see in this case, it's, if I come down a bit, it's not going to be nice. So in this case, I have to do some actual algebra. So let's actually, before I do this, let's just make sure we know how to find the slope algebraically. So the slope is delta y over delta x, sometimes said rise over run. It's good to know that delta is a Greek letter. That means change in. So the change in y from A to MCB is going to be 1 minus 6 over 1 minus 4, which is going to work that out to 5 over 3. So again, if I can't read it off the graph, I want to be able to do this algebraically. So therefore, if I want to find B, I'm going to sub one of my points into my equation with m. So let's sub in, for example, in this case, 1, 1. That's a nice one to sub in. So therefore, 1 is equal to 5 over 3 times 1 plus b. So b is equal to 1 minus 5 over 3. So now we have to do some fractions, and I always like to remind students that fractions are our friends. They are more scared of you than you are of them, and doing a little bit of fraction work every now and then is really good for your health. So we get negative 2 over 3, and now I'm going to, again, ask myself, does this look right? We can see if we extend this down, oh yeah, it's going to be negative. And it probably will be somewhere around negative 1 or so. So I feel good about that. So b is negative 2 over 3. So therefore, the equation of this median is going to be y equals 5 over 3x minus 2 over 3. And the problem is done. So again, in this type of problem, the key thing is to know what a median is. Once you know what a median is, there's not much in terms of new concepts necessarily if you've studied linear equations before and you know how to calculate the midpoint. I hope this video helped.